show you an overview of the TeselaGen Design Module. This module is for people that are working on with DNA sequences and any kind of DNA workflows that include some sort of DNA construction in the lab, and this will make those processes way more easier and faster for everyone. So I'm gonna start quickly showing you a little bit about what we're seeing here, kind of some of the general settings of the platform. Then I'm gonna go into some more specifics. I'm gonna show you how some molecules like DNA sequences can be managed with this piece of software. I'm gonna show you how you can visualize these molecules. I'm gonna show you a little bit how you will create a design so you can use with these molecules that you have uploaded on the platform, and then from these designs generate assembly reports that you can use afterwards to build these sequences in the lab. Also, I'm gonna show you a very quick, very cool tool that will help you build in the lab large DNA sequences that you want to work with. And this tool, what it basically does is it will partition that longer DNA sequence into smaller pieces that you can so afterwards you can assemble it on the lab, and also taking in account any sort of DNA sequence that you already have that can be helpful for building that target DNA sequence. So first, I'm gonna show you a little bit about what we're seeing here. So on the left, we have our module switcher. This will allow you to switch between the different modules of the TeselaGen platform. On the top, we have our lab and project switcher, and also different menu items that are different for each of the modules. So currently we're in the design module, and these are like the menu items for the design module. The labs act as a siloed, distinct instances of the platform for work that must be isolated for security or intellectual property reasons. Normally, most companies start with just a single lab group. I'm here showing my personal lab, which is Hotels Lab. And after companies start working, need more complex data management, they might start add distinct labs. A common example might be different academic labs within a single department, or another example might be different groups within a larger company that must work on distinctly different projects for customers that require data isolation and security. So for setting that up, you will go into settings under lab groups, and here you will just create a new lab group when you can name this lab group, add the people that will be the admin, and add the lab members to the lab group. And after that, you can just create it and keep going. I'm just gonna use the one that I already have created, which is Hotels Lab, and I'm gonna go now to the DNA molecules. So the workflow, the logic of the workflow here is you will upload your molecules first. Afterwards, you will generate a design using these molecules, and from the design you will automatically, like the TeselaGen will automatically generate for you the assembly report, so all of the instructions to assemble all of the constructs that you want to do on the design. And after that, you can get this report and go to the lab. So let's start with some DNA molecules. So as you can see, this menu item here supports a bunch of very common molecules. So DNA sequence, oligos, amino acids. All of these looks pretty similar, like the interface is pretty similar, so I'm just gonna go into the DNA sequences item. So this will load every DNA sequence that you have on the system. I already have preloaded the system with a bunch of them, but if you want to upload new sequences, you can manually create a new sequence, but you can also upload any common use DNA sequence file. For example, TeselaGen will support FASTA files, GenBank. We also support files that are generated from Genius. So all of the common file formats for DNA sequences are supported by TeselaGen. So you can just click here or drag and drop it, and it will you will upload the sequence so you can start working with. The other way that's pretty cool for adding sequences is like we can configure connections with external databases. So it can be an external database, I mean external to TeselaGen, but for example, it can be your organization have an internal DNA sequence database that you want to connect with TeselaGen. This might come from an ELN or any other DNA sequences libraries that you may have internally. We can connect to them. Also, you can connect with NCBI, for example, if you want to directly import DNA sequence information and data from TeselaGen. So what you see here is basically a list, a table with all of your sequences, with the name, size, the type, some of the annotations that so you can see all of the annotations for the sequences. You can see if they are available in inventory or if they aren't, and you have a powerful search bar here where you can, for example, you can filter sequences by and look for what you're looking for. Let me clear this here. And if you click on one of the sequences here, and there's like this small arrow that you can open here, and it will show you a quick view of the specific sequence. So in this case, we have this sequence here. It has a lot of information for this sequence. You can see that there's a plasmid viewer here where you can quickly see all of the annotated features of the sequence, and also there's a list of the features, of the annotated features here. Let me open this specifically one so we can go into more details inside. So this is the plasmid viewer. This is where you will look and annotate your DNA sequences that you have uploaded. You can rotate this, zoom in, zoom out, change to a linear view or like a circular plasmid view, and you can easily annotate things here. You can select a section of the sequence, and you can copy if you want, create an annotation, etc. And on the right, let me show you here, you can also see the amino acid map between the columns. So as you see here, we have an R, D, H, and the corresponding column below. So it's a full-fledged plasmid viewer that allows you to view and handle and manage each individual DNA sequence, and everything is linked. You can double click on a section and it will show you the section, and you have different properties. You can hide the things. You can, for example, hide this feature, show this feature, etc. So that's a quick overview of the Plasmid viewer. Of course, there's a lot more here, but just wanna show you a quick and general understanding on what we have here. So after you have your DNA sequences, you need to create what we call a TeselaGen part. So a TeselaGen part, you can see that we have it listed here, and if we open the Plasmid viewer, it will also show you this like sequences parts. So the sequences parts or TeselaGen parts is what we're gonna use when we are working on our designs. These are usually created directly from features, but you can also create them independently. So you can have your annotations, and from those annotations create parts, or you can just have like parts annotation and manage them separately. That will depend on how you prefer to work. But let me go here again, and I'm gonna show you, for example, this whole part here is what, no, sorry, this whole part here is what we call, we gave it a name as a vector. This would be a vector backbone, but as you see, it includes many annotations internally, and you can annotate, you can make parts from these annotations also if you wish so. So you can just create a part from each of the features. After you have your DNA sequences and you have created your parts, you can go to the design part of the workflow. So I'm gonna close this here, and I'm gonna jump into the designs. So here's where the design work will be executed. So the idea here is like after you uploaded your DNA sequences, you want to create a combinatorial library of different constructs that you want to, like afterwards, that you want to build on your lab. I'm gonna show you. So for creating a design, you can create a new blank design, or you can, if it's your first time playing around with the platform, you can start with an example design, so you can have a starting point and better understand what's happening here. I'm gonna start with an example design. I already have created one, which is this combinatorial golden gate, and that one I created it from here, and it basically is gonna create, let me show you a blank design before, and then I'm gonna show you how a populated design, like the example design that I created, will look like. So here you can just you can just add a name, and just, you need to add it to a lab. And this will show you the design view. So it's kind of a spreadsheet where you have rows and columns. So you can add columns here. We call them bin, but they're basically columns. And you can also add rows. And in each of these cells, you can start working with your DNA sequences. So here you can double click and add a new DNA sequence. The things that you can add are the DNA parts that I mentioned before. So here you will have a window that will show you all of the DNA parts that you have on your that you have created on the TeselaGen platform. So say that we want to use the vector backbone part that I showed you before. We can see this there, but we can also use the search bar over here, and you can just select, for example, let's use this vector backbone. And that's how you start working with your design. So let me go, I'm gonna go back to the combinatorial Golden Gate example design that I have created. So after you start adding the specific parts and to your design, you will get something like this. So here now we have a fully designed library that has 8 constructs. This is a combinatorial library, so the number of constructs are like, you calculate them by taking 1 times 2 times 2 times 1 times 2 times 1, so that will give you 8. Of course, we calculate that for you automatically here, so you can understand how many possible combinations you already have. This is a pretty simple design. As you see, vector backbones and SIGPEPs, linkers, GFP, in here. It's pretty simple, it's just for the demo. And if you would want to keep adding, as I said before, you can keep adding rows or you can add columns. Similarly, and how on the DNA molecules library, you could just click and see a quick view of what you have clicked on the right. Here's the same idea. So if I click here, you can see the plasmid viewer on the right and some information around this. And you can add notes if you want. You can force assembly strategies for each of the parts if you want so. And you have many things that you can tweak, so the assembly process can look exactly how you would look like for your specific workflows and experiments that you want to run afterwards. It has fully collaboration features, so you can comment on the design. I'm not gonna go into details here, but you can define a specific design review process. So for any designs that your organization works, you can customize a specific design review process that all of the designs need to go through before going into assembly. And when you have everything ready, you select your assembly method. In this case, we're using Golden Gate, so we need to select our restriction enzyme. You can change or template how you want the names to be, because this is gonna generate 8 possible constructs, and from those it will generate some oligos, some PCRs. So all of those things that's gonna be generated, you can define naming templates, so they can be generated accordingly with some naming convention that you might use internally. Every assembly method, so we support a bunch here. For every assembly method, you have the specific assembly parameters, so you can really tailor your assembly process for each construct. For example, some important things that you can tweak here are the primers, max size and min size. You also can change the TMs, the homology length, etc. There's a lot of things that you can tweak here. When you have everything set, if you wanna change it, you can just save. I'm just gonna cancel because I'm not changing anything here, but I just wanted to show you that you have a lot of levers that you can tweak for your specific workflows and assembly methods. You have your assembly parameters configured and everything ready. you can proceed to generating the assembly protocol for this combinatorial library. And generating the assembly protocol is just as easy as clicking the button here, and everything will be calculated and generated on the backend for you. This can take some time depending on the complexity of the design, and you can track the process of the assembly protocol generation here under tasks. So this is the last one that I just sent. This is one that I previously sent. You can see that it's completing. So there's a couple of ways and how you can open these assembly reports. One is you can just go back to your design, and on the right where I show you these different menu items, there's one that shows all of the assembly reports that are linked to this design. So here you can just click one. I'm gonna click on the last one, which is the one that we just generated, and will open the assembly report for you. Here you can have a quick view of everything that you're gonna need to do in the lab and what you're gonna get after that work on the lab. So on this card here, assemble constructs, let me refresh here. Yeah, so on the assemble constructs, you will see all of the final constructs that you're gonna have after you run these assemblies. So we have the 8 constructs that we mentioned before, that we're gonna have 8 from the design that we started with. You can see all of the parts that are contained in each of the constructs. You can open them on the vector viewer and see how the assembled construct is gonna look like. It's gonna be fully annotated with the original annotations, plus it's gonna indicate to you the assembly pieces. For example, this is the assembly piece that was used for this assembly for this construct, and here you can see there's another assembly piece. And these pieces contain like the vector, the GFP, the SIGPEPs, and everything that we had on our design previously. Let me go back to the assembly report. So these are just a bunch of cards, and this card on top is the finalized constructs. But then if you keep scrolling a little bit down, you can see that here you can find the assembly oligos that were generated by TeselaGen automatically, and it calculated everything. So it generated the oligos and also calculated the melting temperatures for these oligos and everything that you need. And if you keep scrolling down, you can see that also generated the PCRs, which the oligos that you need to use for each of the PCRs with the corresponding template, the TMs, and everything here. So yeah, and at the end, these are like the assembly pieces that you're gonna use to assemble the final constructs. And at the end, you can see again the finalized constructs. Everything can be open and you can see it on the vector viewer. So for example, if you want to see one of the oligos that were generated, you can just open it here and I will show it to you. This is the oligo. Pretty simple. So that's on the assembly reports. But sometimes designs can have issues, warnings, and things that might make it impossible or difficult to assemble it on the lab. So TeselaGen will catch all of this beforehand. In this case, this specific example doesn't have any warnings, But let me go to the reports table. Here we have all of the reports that I have generated in this lab, and as you can see, there are some that has like these warnings. To view the warnings, you can quickly just click here, or you can open the report and click view warnings, and it will show you the warnings. And we have like 3 types of warnings. Medium and high priorities are ones that you need to look into. High priorities probably gonna your assembly is gonna fail, so you need to be very careful with those. Medium also, they're worth a look. Low priority are usually just fine. You can just keep moving forward. Still, they are there. You can look at them, but it shouldn't be as critical as these other 2 types of warnings. And like in the reports, you can actually see specifically which constructs are gonna have issues. So here we have a bunch of them that don't have any warning, so you should be good to assemble those in the lab. But there are a few that have some warnings attached to them. That's on the reports and the reports view and the warnings. All of this is generated automatically by TeselaGen from your design on our backend. But as I mentioned initially, there's another important use case here that I want to show you quickly, which is what happens if you have like a longer DNA sequence. You already know how the sequence is gonna look like, but you want to assemble it on the lab. You want to synthesize it in the lab. So what TeselaGen offers is what we call the partitioning tool. So the partitioning tool will grab a longer DNA sequence. It will grab a longer DNA sequence and partition it in subparts that can be safely assembled in the lab following your preferably assembly method. And also, if you have pieces of DNA in the lab that you can use to assemble that DNA final construct, it will TeselaGen will take in account what you have in the inventory to generate the assembly instructions for that specific DNA sequence. So let me show you here. So for example, we already have no, let me select this one here. As similarly as before, you can template the naming depending on how your organization and your team likes the convention that you have, and then you can just go next, and then you configure how you want to assemble this sequence. So you can select the assembly strategy. I'm gonna select Gibson for this one, and then you have a bunch of parameters that you can tweak depending on what you would like to. I'm gonna select here. You can see if TeselaGen can find the corresponding relevant sequences that you can use to assemble this final construct without needing to order new DNA to an external DNA provider or so. And then you just submit. And what's gonna happen here, this is gonna create a design for you. So now if you go to designs, this is gonna process for a while. So I'm just gonna show you a design that I already have from the partition. This one here, it's one that I created with the partitioning tool, and this sequence was partitioned in 3 subsequences. So afterwards, the partitioning tool will generate for you the design, and it's basically ready to assemble. So you just go and submit for assembly, and the flow is basically the same as before. You submit for assembly, you can review that everything is fine, and then you just go into the reports, and this was gonna take a while, but when it finishes you can see this is the one that we sent before. You can see that it calculated the oligos for you, also melting temperatures, everything, the symptoms, everything that you're gonna need to synthesize, to build this in the lab, this target sequence in the lab. So thank you very much for looking into this. This is a quick overview and general overview of the design module. There's more things that you can do and go deeper, and things that you can tweak, but I just wanted to show you a quick, simple overview and how like a workflow will look like, and how you can use this to really make the work in the lab way easier, automating a bunch of manual things that you need to calculate. And so thanks again for watching, and if you have any questions, you can go to our website, contact us, and we're gonna be happy to help.